Hi, this is Faris and this will be Chemistry Week 8 CA. Which of the following equation shows the melting process of water in ice cubes? We know melting is endothermic and from solid to liquid. Now, so melting, if you don't remember that it's endo, uh, we know that it's from solid to liquid, and solid, liquid, gas breaking bonds is endothermic, forming bonds is exothermic. So since it's endothermic, the energy will be on the reactant side. So H2O plus 6 kilojoules. Now there is also this one, the energy is in the reactant side, but saying the melting. So again solid to liquid, so from S to L. What is a volatile substance? A volatile substance is a liquid, we said that before a lot, a liquid that evaporates readily without any change in the temperature of it. Like at room temperature it evaporates like alcohol. A specific volume of liquid water was placed in a beaker and heated to its boiling point. Which of the following statements is true? We know in a heating curve, temperature goes up until the boiling point وبعدين the temperature stays constant علشان the energy from the heat is getting absorbed into the bonds of the molecules so it can break them. So the temperature of the liquid does not increase and energy is absorbed. The heat absorbed while the water is boiling causes the liquid water to evaporate. Yeah. The heat applied while the water is boiling does not raise the temperature. Also yes. The input of heat causes the temperature to decrease. That never happens. Even if the energy isn't absorbed, heat will cause the temperature to increase, not decrease. The temperature increases as the liquid releases energy. The liquid is not releasing energy, the liquid is absorbing energy. A pan of liquid water is heated. At a certain point, the water begins to boil. Again, we said that since it's boiling, it's endothermic. علشان we're breaking the bonds from liquid to gas. So energy is in the reactant side, H2O liquid, so from L. This one is also the energy is in the reactant side, but here it starts with gas, so it's wrong. So H2O liquid plus 42 kilojoules produces H2O gas. The other two, the energy is in the product side, meaning it's exo, and it's wrong. The reaction is endo. The process is an endothermic process, not exothermic. Which of the following mixtures can be separated using filtration? Again, filtration is used when an insoluble solid in a liquid. So oil and water, these two are two immiscible liquids, so not filtration. Salt and water, homogeneous mixture, the salt dissolves in the water, use distillation for that. Sand and water, sand is insoluble in water, so you use filtration. Sand and iron fillings, neither of these dissolve in water or there is any liquid, so you can't use filtration. So it's wrong. Which of the following is an ion? Now an ion is any particle carrying a charge. So an atom carrying a charge, yeah. An electron node, that's part of an atom. A molecule carrying a charge, yeah. A neutral compound, no, we want it to be a charged compound. No. What is a saturated solution? A saturated solution, you have to memorize this definition. A solution in which the maximum amount of solute is dissolved in a fixed amount of solvent at a certain temperature. You have to say that the maximum of the solute in a fixed amount of solvent, and don't forget in a certain temperature علشان we took before the temperature can increase the rate of solubility. A solution in which an excess of solute is dissolved in a mixed amount of solvent at a certain temperature, no, not an excess, we want the maximum. A solution in which 1 mole of solute is dissolved in 1 liter of solution at certain temperature, no, that's wrong. A solution in which the solvent can dissolve more solute, no, that's not saturated. When we say saturated, that no more solute can be dissolved into the solvent. Here they want the properties of molecular solids. We know molecular solids have low boiling and melting points. And some of them, like acids, HCl for example, can form ions when dissolved in water. So molecular solids have low melting points, correct? Some molecular solids interact strongly with water to give conducting solution with ions. Yes, some of them, not all of them, so correct. Molecular solids have high boiling points. No, they have low boiling points. Molecular solids are bonding together through ionic bonds. No. They're bonded through molecular bonds. Ionic bonds are for ionic compounds. Check the properties of ionic solids. Ionic solids are like the total opposite of molecular solids. They have high boiling points and melting points. And almost all of them dissociates into ions when dissolved into water, forms ions. Almost all of them, not all of them. And they have the structure of a lattice. So a lattice is a charged ion is connected to six others oppositely charged atoms, one from each side. So it would look something like that. That's a lattice. So low melting point, that's incorrect. High boiling point, yeah, we just said that. Forms crystal lattice, also command correct. And conducts electricity when molten. There are two ways to conduct electricity. Either the ionic compound is dissolved into water or melted. This is how you can conduct electricity through them. Now كمان at the blank, the vapor pressure becomes equal to the pressure above the surface of the liquid, and bubbles of vapor can form anywhere within the liquid. Now if you don't know this, we know that the boiling point is when the vapor pressure, just like the question said, when the vapor pressure outside the liquid is equal to the pressure inside the liquid, so bubbles can form anywhere. But here they said and vapor and bubbles of vapor form anywhere within the liquid. So we know that vapor is in the gas form and form bubbles. So what can you say bubbles happen? When it's vaporizing, it boils. Literally, that's it. You don't need anything for this. You can just either memorize it or just bubbles and boiling point. For this question, they want us to arrange the boiling points. We know as the altitude increases, the boiling point decreases. So as long as we're going up, the boiling point goes down. So at sea level, it's 100 degrees Celsius. When we see our options, it is the greatest one. 100 is the biggest one. And then above that, 98.2, and then 95 and 89. It goes like that. The more you go up, the lower the temperature. Also for this question, if you're not sure about it, check the background of the thing. You're gonna see here that there are lines. If you're not sure, check if the lines are matching from the picture, because they get the options from the image itself. They just crop it out. So check if the lines are matching. This is another way to know if your answer is correct. At the same temperature, the blank of molecules in the solid, liquid, and gaseous phases of a substance is the same. We know Ke, kinetic energy, is proportional to temperature. So when the temperature is constant, kinetic energy is constant, and when the temperature is equal to each other or the same, kinetic energy is the same. So at the same temperature, the average kinetic energy of molecules in the solid, liquid, and gaseous phases of a substance is the same. At the same temperature, same kinetic energy, average kinetic energy. You also need to just memorize this. The gas particles have the highest potential energy. That's it, you just need to memorize it. Gas particles have the highest potential energy. That's it. We also said this for the periodic and last week's CA. Any beaker containing ethanol or alcohol cannot be heated using a direct flame. You need a water bath or an electric heater. That's it. You can't put it into a direct flame, so you cannot heat it using a Bunsen burner. So a beaker containing ethanol solution should never be heated using a Bunsen burner. Which of the following techniques is used to separate black ink into components? So here they want the technique used to separate black ink. Now when you see they want to separate black ink, directly go to paper chromatography. You don't need to do anything, just paper chromatography with black ink or ink عامة. Just when you see ink, go to paper chromatography. Again, we said this before, copper sulfate, always crystallization. You don't need anything for it, just crystallization. You see copper sulfate and they want to get the solid, crystallization, always. Which of the following is a solution? Now a solution is a homogeneous mixture. So it means homogeneous, it appears as one phase. So here in the fizzy drink you can clearly see the liquid and the gas up here. So it's wrong. Oil and water, they don't appear as one. You can clearly see the oil and the water separated, so no. Ethanol and water, you can see it as a clear liquid, so you can see it as one, correct. Orange juice, you cannot see it, but if you look really closely in a real life one, you'd see that there's the pulp of the orange in it, so it's no. It's more than one phase. It's not dissolved in it. This question came before. It came in the periodic and it came in last week's AMS. What is the molar concentration of 1 decimeter cubed solution in which 0.5 moles of sodium carbonate Na2CO3 is dissolved? So C equals N over V. N is 0.5, V is 1. You put it in your calculator. 0.5 divided by 1. You get 0.5. Two significant figures, you add the trailing 0.5 m molarity. So 0.5. How many moles of sodium carbonate should be dissolved in 0.10 decimeters cubed of water to make a 0.5? Okay, so they gave us the molarity, the concentration, and they gave us the volume. They want the moles. N equals CV, so N is 0.5 times 0.1. You can put it in your calculator. 0.5 times 0.1. You get 1 over 20 or 0.05. Again, two significant figures. So 0.050 moles. What volume solution should be used to dissolve 0.10 moles of sodium carbonate, knowing that the concentration resulting is 0.2? Suppose the volume of sodium carbonate is negligible. Now for part C, we know that there is this equation V equals C over N. N over C. Yeah, so N is the moles, 0.1, over the concentration, 0.2. You can put it in your calculator or do it in your mind. So you get 0.5, two significant figures, 0.50, and volume, so decimeter cubed. A student wants to prepare 100 centimeter cubed of 0.1 molarity sodium carbonate solution. Find the mass of sodium carbonate. So I know sodium carbonate from the beginning of the question, Na2CO3. Na2CO3. So we want the mass, so we first find the moles. 100 centimeter cubed, we want it in decimeter, so you divide by 1000, you get 0.1 decimeter cubed. So N equals CV. N is the concentration is 0.1, volume 0.1, so 0.1 times 0.1, you get N equals 0.01 moles. And we want the mass, so M equals N times molar mass, capital M. Molar mass 2Na, so Na is 23, 2 times 23, plus C is only 1, so 12, plus 3, and the molar mass of oxygen is 16, 3 times 16. This full thing you get the molar mass is 106 multiplied by 0.01. You get 53 over 50, or exactly 1.06 mass, so grams, and it's already 3 significant figures. So when they want the mass, first you find the moles, then you multiply it by the molar mass. Give the formula for the ionic compound formed from each of the following pairs of ions. Now Mg2 plus and O2 minus, they have the same exact number, so the charge, opposite charge, but same number, so they cancel. MgO is the answer. بعدين NH4 plus and Cl minus, again since there is no number, it's 1, exact same number but opposite charge, so they cancel. Ca2 plus and N3 minus, these two they don't cancel. Ca2 plus and N3 minus. You do the crisscross method. The 3 of the N goes to the Ca, so Ca3 becomes a subscript, and the charge of the Ca2 goes to the N, becomes a subscript, N2, Ca3 N2. Part D, Al3 plus and SO4 2 minus, again crisscross, Al2, the charge of the SO4 of the sulfate ion goes to the Al, becomes a subscript, and SO4, don't forget the brackets علشان there is already a number and you want the 3 for the whole sulfate thing, so Al2 SO4 3, don't forget the bracket. Now this came in the periodic quizzes, and I said I will skip it علشان it's not coming, and it did not come in the periodic, but now it's coming in the AMS. We took it, so we should know it. So for this question, they want the moles of each ion. So we find the moles of each ion. They want the moles of each ion. First, we write the balance equation. So CrNO3 3 crystal so solid produces Cr. They already gave it to us, Cr3 plus aqueous plus NO3 also aqueous. The charge of NO3 is minus, so minus. Here we have 3 ions of NO3 علشان the bracket and the 3 here, so 3 NO3 and 0.5 moles of the solid, so 0.5. And then to find the moles of each ion, you multiply the moles of the solid we began with by the coefficient. So 0.5 moles. Here coefficient is 1, so 1 times 0.5. And here the coefficient is 3, so 3 times 0.5. 1 times 0.5 for Cr is still 0.5. 2 significant figures, you add a trailing 0. And 3 times 0.5 is 1.5. It's already 2 significant figures. But the moles for NO3 is 1.5. That's how you get it. So if they want the concentration, you get the moles and divide it by the volume in decimeter cubed. Here the volume is in milliliter, so we want it in liter. Decimeter cubed and liter are the same thing, they equal each other. So we divide by 1000, you get 0.1. Now they're not asking for the concentration in this question, but I'm showing you how to get it in case they ask. علشان in this quiz there is no question about the concentration. So 0.5 C equals N over V. N is so the concentration of Cr3 plus is 0.5 over 0.1 equals 5. And if they ask in this question 2 significant figures, 5.0 molarity, and the concentration of NO3 minus is 1.5 over 0.1 equals 15. Already 2 significant figures, capital M for molarity. So here in this question they asked for the moles. This part is the moles, and if they ask for the concentration, this is how you get it, using the C equals N over V. They did not ask for the moles again, they did not ask for the concentration, so again for this question only the moles. Complete the chemical equation for the dissociation of iron 3 chloride, FeCl3. So in this question, the one they gave us, the only thing they didn't put is the 3 here. So FeCl3, we first see how many atoms of each we have, Fe1 and Cl3. So Fe is balanced, 1, since no coefficient is 1, and Cl3 and Cl, we have 3 atoms to begin with, so we need to put a coefficient of 3, and that's it. For the next 2 questions, you need to memorize this: anions, negatively charged ions, and cations, positively charged. There is this thing, my last year cert used to say, cats make you feel positive, so cations are positively charged ions. That's it, that's all you have to know. For this question, they want the symbol of the following: calcium ion. Now, in the exam hall, you can ask for a periodic table, and there's this way. So calcium ions, they're in group 2. So 2, you have the calcium here, 3rd period. So since since it's group 2, the charge is 2 plus. Group 1 is 1 plus. Group 3 is 3 plus. No, sorry. Group 2, 2 plus, and then you have the group 1, 1 plus, group 2, 2 plus, and then you have the transition metals. The charges for these vary. Group 18, they don't have a charge, they're neutral, they have full valence electrons. 17, like Cl, 1 minus. 16, 2 minus. 15, 3 minus. And 14, 3 plus. 13 is a bit confusing علشان there are non-metals, so you don't need to know it. So calcium ions, group 2, third period. So group 2, 2 plus. Chloride ions, so Cl, chlorine. Group 17, Cl, 1 minus. Again, since it's 1 minus, you don't need to put the numbers, just minus is enough. Copper, and they give you II, Roman numeral for 2, ion. So علشان it's metal, so the charge is positive, and they gave it this Roman numeral II, so it's plus 2. They gave you copper 2 ion, so it's plus 2 plus. It's plus علشان it's metal, we said that. Now for sulfate ion, these are the ones that you have to memorize from the table that is in the either in the course practice document or the book. SO4 is 2 minus, sulfate is 2 minus, you have to memorize it. Also, you have to know that sulfate is SO4. For this question, they want us to name them. It came in the written part in the periodics, so you should know it by now. But anyways, AG, part A, AGI. Here, A, capital A, small g, and capital I. So the I is a different element by itself. Ag is silver. You can get it from the periodic table. They give it to you in the exam hall. And I is iodine. So silver iodide. علشان ions, they end in IDE. We say iodine for the element itself. But when we're talking about ions, it's not iodine, it's iodide. IDE. Almost all of the ions end in that. Silver iodide. For the anions, cations, they stay the same. Pb, SO4. Pb is lead. They told us in school that when we write lead, we always have to put the bracket and write II for it. And SO4, we know from the other question, it's sulfate. So lead and the Roman numeral 2, sulfate. You also need to know spelling. And 3, Li, 2, CO3. Now, this one has subscripts. But when we're naming ionic compounds, we don't say dioxide or di something or tri something. We don't put prefixes. So just act like the 2 and the 3 don't. Just act like the 2 doesn't exist. The 3 is part of the CO3. CO3 is a carbonate ion. You should also know it from the table. So since it's carbonate, the 3 is part of it. You don't remove it. But the name of that ion is carbonate. So lithium for the Li, and CO3 is carbonate, lithium carbonate. Now if they gave you a dichromate ion, Cr2O7, this is a dichromate ion. The di, you have to put it. It came in the written part and a lot of people got it wrong. علشان they told us not to put the di or the prefixes. But this is its name is dichromate. You have to put the di. It's not an option, it's in the name itself. Here they want us to differentiate between network solids and metallic solids. So network solids, we only took 3 at school. It's graphite, diamonds, and SO2. SO2 is SiO2, sorry. SiO2. So silicon dioxide, diamonds, and graphites. These are all of the network solids we took. And metallic solids are حرفيا any metal. Metallic solids, any metals. So network solid, diamonds, and silicon dioxide. And metallic solids, gold and iron. These are the only 2 metals here anyways. This question, the vapor pressure of a water flask blank when the temperature remains constant. We know that pressure also directly proportional to temperature. So when temperature stays constant, pressure remains constant هو كمان. So vapor pressure of water in flask remains constant when the temperature remains constant. وكمان in this question they're talking about vapor pressure. We know that vapor pressure is the pressure of the liquid, is the pressure of the particles above the surface of the liquid. So as temperature remains constant, no more particles evaporate, so the pressure stays the same. For this question, the energy required to vaporize The energy required to vaporize 18 grams of liquid water at a constant temperature is 42 kilojoules. Predict the energy required to melt an 18 grams ice cube of constant temperature by completing the equation below. Now they want the melting point. For vaporizing point, it's to evaporate liquid water. Now the energy needed to melt is less than the energy needed to evaporate. So 42 kilojoules is the energy needed to evaporate it. 100 kilojoules is more than that, so it's wrong. And 6 kilojoules is the only thing that's less than it. So it's just 6 to melt an ice cube. Again, command for this question, you take it approximately. The greatest one with the biggest one. Biggest one copper with 1083. So you take the biggest one 13. Water second biggest with 0. So you take the second biggest one 6.02. Neon minus 2 48.4. Smallest one, you take the smallest one here 0.334. Drag and drop the correct answer to complete the sentence. A blank is a homogeneous mixture. We know a homogeneous is a solution. So you just, this is common sense really على فكرة. So homogeneous when the solute dissolves in the solvent and they form a solution. Just common sense, you don't need anything. The separation technique used to separate 2 solids based on their difference in solubility is selective solubility. Again, this is حرفيا the definition of selective solubility. You need to know it. And they literally tell you the answer is in the question. Difference in solubility to separate it. So selective solubility. We said this many times before in previous AMS weeks. Mixture of water and ethanol is separated using fractional distillation. Water and ethanol, they both have almost the same boiling point. Water 100 and ethanol I think 78 or something like that. So they have close boiling points. So normal distillation doesn't work for it. So fractional distillation. Again, here they want the definition of an aqueous solution. So any aqueous solution is just the solution and the solvent being water. The only thing different about it and any solution that the solvent is water. So when the solvent is water, it's an aqueous solution. 2 liters of 1.0 moles of NaCl solution is prepared in a flask. So 400 milliliters of the solution is poured into a beaker. So they're talking about the same solution in both sentences here. They say of the solution, and the solution has 1.0 molarity. Since it's from the same solution, they have the same concentration, so the concentration of the salt solution in the beaker, it's 1.0. Two significant figures, 1.0 m. Here they want the separation technique for salt and water. We know paper chromatography is for ink, for example, to know the different components of it, so not salt and water. Here it's a separatory, it's filtration. It's a separatory funnel, 2 liquids, water and oil, for example. So 2 liquids here, no, solid and water. Salt is a solid. And here is distillation. The only thing that works here is distillation, so it's correct. And these are all of the questions عشان chemistry week 9. Question 28 is skipped for some reason, so I'm doing it again here. In this question, they want the molar heat of vaporization compared to the boiling point. Here, in these kinds of questions, you take the value approximately, not the exact same value. You don't need to memorize it. Here, the biggest one is copper with 2582. So, this is the biggest one. Molar heat of vaporization is directly proportional to the boiling point. Since this is the biggest one, you go into the options and check which one is also the biggest one. So 304 here is the greatest one, so you put it beside copper. Sodium chloride is the second biggest, so you go and check the second biggest, 170. So you go put it here, come on. So, and then 889 is the second smallest. You go check, the second smallest one is 101, you go put it, and minus 34.1 is the smallest one, so you check the smallest one and it's 20.4, so you put it there. That's it.